Good morning, dears. We were discussing about rational numbers. In the last two class, we discussed about rational numbers. Okay, properties of rational numbers, how to represent a rational number on a number line like that. That was our first chapter. Now we are moving to our second chapter. The chapter also related to rational numbers. Okay. The name of the chapter is Operations on Rational Numbers. Then first operations of rational numbers means in this chapter we are going to discuss some properties of rational number. Properties of addition of rational numbers, subtraction of rational numbers, multiplication of rational numbers and division also. So first we are discussing properties of addition of rational numbers. Properties of addition. Listen, and I think you are familiar with these properties because these same properties we were discussed for natural numbers, whole numbers and integers also. So same properties we need to check the same properties are applicable for whole numbers also. Then first property, do you know which is the first property? Always we are starting with the closure property. Closure property. Do you know what is this closure property? Then what is closure property of natural numbers under addition? If we have two natural numbers, suppose we can take two rational numbers 2 and 3. When we are adding these two numbers, 2 plus 3 is 5. Here 2 is a natural number, 3 is another natural number and our answer is sum is 5. 5 is another natural number. That is, when we are adding two natural numbers, our sum is also a natural numbers. So we can say closure property is applicable for natural numbers. Same way we need to check this property is applicable for rational numbers or not. So we can take two rational numbers 1 by 2 and 2 by 3. Here we have two rational numbers. Then we are adding these two rational numbers 1 by 2 plus 2 by 3 equal to, here 1 by 2 plus 2 by 3 means we need to equalize the denominators for adding the rational numbers. So 6 is the LCM of 2 and 3. Then so here 2 into 3 is 6, so 1 into 3 plus 3 into 2 is 6, therefore 2 into 2. Then 1 into 3, 3 by 6 plus 4 by 6, that is 7 by 6. Which type of number is 7 by 6? Is it a natural number? Is it a whole number? Is it an integer? No. 7 by 6 is a rational number. Okay. So when we are adding two rational numbers, our sum is also a rational number. Okay. So we can conclude that the sum of any two rational number is also a rational number. That is our closure property. And second property, commutative property. Commutative property. What is commutative property of natural numbers? We can add two natural numbers without considering the order of numbers. Suppose 2 plus 5. 2 plus 5 is 7 and 5 plus 2 is also 7. That is, we can add two natural numbers in any order. Same way we need to check, is it applicable for rational numbers or not. So we can take two rational numbers, any two rational numbers, 2 by 5 and 4 by 5, two rational numbers. Suppose A equal to 2 by 5 and B equal to 4 by 5. Then A plus B is equal to 2 by 5 plus 4 by 5, which is equal to 6 by 5. Then we are adding B plus A. B plus A equal to 4 by 5 plus 2 by 5, which is also equal to 6 by 5. So 2 by 4 plus 4 by 5 is equal to 4 by 5 plus 2 by 5. So we can say that for if A and B, suppose this A and B are any two rational numbers, any two rational numbers, then what we can say, A plus B equal to A plus B equal to B plus A. That is commutative property. A is a rational number, B is another rational number. Then we can add two rational numbers in any order. Then third property is associative property. To verify associative property, we need three rational numbers. Associative property. Suppose A, B, C. These are three rational numbers. Then associative property means A plus B plus C. We need to add these three rational numbers. Instead of adding these three numbers together, first we are adding the first two numbers, then the second number, equal to A plus B plus C. What is the difference between LHS and RHS? In the LHS, first we are adding the first two numbers, and in the RHS, first we are adding the last two numbers. Okay, we can take one example. Suppose A equal to 1 by 3, B equal to 2 by 3, and C equal to 4 by 3. Three different rational numbers. Then we can verify this property. First, A plus B plus C. First we are adding the first two numbers. So A is 1 by 3 plus B is 2 by 3 plus C is 4 by 3. Listen, we need to verify A plus B plus C is equal to A plus B plus C. Now we are proving the first part, LHS. Then 1 by 3 plus 2 by 3. Denominators are same, so we need to add the numerators. 1 plus 2 is 3 divided by 3 plus 4 by 3. This 4 by 3. Then 3 plus 4. Here also the denominators are same, so add the numerators. 3 plus 4, 7. 7 by 3. So A plus A plus B plus C is equal to 7 by 3. Next we need to check the RHS. A plus B plus C equal to, here A is 1 by 3 plus B plus C. B is 2 by 3 plus 4 by 3. Then first we are adding B plus C. 1 by 3 plus 2 by 3 plus 4 by 3. 2 plus 4, 6 by 3. Then 1 by 3 plus 6 by 3. 1 plus 6, 7 by 3. So here A plus B plus C is 7 by 3 and A plus B plus C is also 7 by 3. So we verified associative property A plus B plus C is equal to A plus B plus C. This is the third property. Then fourth property is, I think it is clear. These all properties we already discussed for natural numbers, whole numbers and integers. Now the numbers, only the difference for numbers. Now the numbers are whole numbers. Sorry, now the numbers are rational numbers. And fourth property, additive identity. Additive identity. What is identity? Listen, additive identity of natural numbers, that is 1 is a natural number and if we are adding 1 plus 0, our answer is 1 itself, and 0 plus 1 is also equal to 1. So we will say 0 is the additive identity of natural numbers. Same way, if you are adding 0 to any rational number, 1 by 3 plus 0 is 1 by 3 and 0 plus 1 by 3 is also 1 by 3. So we can say that 0 is the additive identity of rational numbers also. That is, for any rational number A plus 0 equal to 0 plus A equal to 0. So which is the additive identity of rational numbers? 0. Next, additive inverse, last property of addition. Additive inverse, fifth one is additive inverse. Okay, additive inverse means, what is 3 plus negative 3? 0. 3 plus negative 3 is equal to 0. So we can say that 3 is the additive inverse of negative 3 and also negative 3 is the additive inverse of 3. Okay, so additive inverse means, suppose take a rational number other than 1 by 3, 4 by 5. It is a rational number and 4 plus dash equal to 0. 0 means our additive identity. Which number we need to add to 4 by 5 to get 0? Which is that number? Here we have positive 4 by 5. If you are adding negative 4 by 5 to 0, we will, negative 4 by 5 to 4 by 5, we will get 0. So we can say 4 by 5 is the additive inverse of negative 4 by 5, and also for negative 4 by 5 is the additive inverse of 4 by 5. So that's all about properties of addition of rational numbers. Listen, today we just discussed only about properties of addition of rational numbers. First property was closure property. Closure property. Commutative property. Associative property, then additive identity and additive inverse. Listen, closure property means if A and B are rational numbers, then A plus B is also rational numbers. Okay, that is closure property. Then commutative property. Here also we need two rational numbers. Suppose A and B are the two rational numbers, then we can add any two rational numbers in any order. A plus B is equal to B plus A. And third property is associative property. So here we need three rational numbers, A, B and C. Then A plus B plus C is equal to A plus B plus C. Okay. Then additive identity. Which is the additive identity? 0 is the additive identity. And additive inverse means if you are adding a rational number to another rational number, then our sum will be 0. Okay. Example, additive inverse of 5 by 6 is negative 5 by 6. I think all the concepts are clear. That's all for today. Thank you.